SVM helps AI draw the smartest boundary, separating customers, risks, fraud, and decisions with clear classification logic for business outcomes. Now let's look at SVM separates data into classes. Support Vector Machine, or SVM, is a supervised machine learning algorithm. It is commonly used for classification problems. Classification means predicting a category or class. SVM tries to separate different classes using the best possible boundary. That boundary is called a hyperplane. The main idea is simple: separate classes with the widest safe gap. This makes SVM useful when clear separation matters. Now let's look at what you will learn. First, we will understand what SVM means. Then we will see why SVM is used for classification. Next, we will explain hyperplane, margin, and support vectors. After that, we will compare linear and nonlinear classification. Then we will explain the kernel trick in simple language. Finally, we will use business examples and common beginner mistakes. Now let's look at what is support vector machine. SVM is a machine learning method used to classify data. It learns from examples that already have labels. For example, transactions may be labeled as fraud or not fraud. Emails may be labeled as spam or not spam. Customers may be labeled as high risk or low risk. SVM studies these labeled examples. Then it learns a boundary that separates the classes. Now let's look at why SVM is used for classification. In classification, the model must decide which class a new case belongs to. SVM is useful because it focuses on separation. It tries to find the boundary that best divides the classes. It does not just draw any boundary. It looks for the boundary with the maximum margin. This can make the model more stable on new data. SVM is especially useful when the classes are clearly separable. Now let's look at hyperplane explained simply. A hyperplane is the decision boundary used by SVM. In two-dimensional data, it looks like a line. In three-dimensional data, it looks like a flat plane. In higher dimensions, we still call it a hyperplane. You can think of it as the separator between classes. One side may be Class A. The other side may be Class B. Now let's look at margin in SVM. The margin is the gap between the boundary and the nearest data points. SVM tries to make this gap as wide as possible. A wider margin means the classes are separated more safely. This helps the model handle new data better. The best hyperplane is not only about separating the data. It is about separating the data with maximum margin. Margin is the reason SVM is powerful. Now let's look at support vectors. Support vectors are the most important data points near the boundary. They are the points closest to the hyperplane. These points influence where the boundary is placed. If support vectors move, the boundary may change. Points far away from the boundary usually matter less. SVM focuses strongly on these critical boundary points. That is why it is called support vector machine. Now let's look at a simple visual example. Imagine red dots and blue dots on a chart. SVM tries to draw a line between them. But many lines may separate the dots. SVM chooses the line with the widest margin. The nearest red and blue points become support vectors. This line becomes the decision boundary. New dots are classified based on which side they fall on. Now let's look at linear classification. Linear classification means the classes can be separated by a straight line. If the data is simple, a straight boundary may work well. For example, low-risk and high-risk customers may separate clearly using two features. A linear SVM can draw a simple boundary. Linear SVM is easier to understand and often faster. It works well when the relationship is not too complex. But real data is not always that simple. Now let's look at nonlinear classification. Sometimes classes cannot be separated by a straight line. The data may be curved, mixed, or complex. A straight boundary would make many mistakes. This is called a nonlinear classification problem. SVM can still help in many of these cases. It uses kernels to create more flexible boundaries. This is where the kernel trick becomes important. Now let's look at kernel trick explained simply. The kernel trick helps SVM handle complex data. It allows SVM to separate data in a higher dimensional space. In simple words, the data is transformed so separation becomes easier. A pattern that looks mixed in one view may become separable in another view. The model does this without manually creating all new dimensions. Common kernels include linear, polynomial, and RBF. The kernel trick helps SVM solve nonlinear problems. Now let's look at business example. Fraud detection. Fraud detection is a common classification problem. Transactions can be labeled as fraud or not fraud. Features may include amount, location, time, device, and customer behavior. SVM can learn a boundary between normal and suspicious transactions. New transactions can then be classified based on that boundary. High-risk transactions may be sent for review. This helps banks reduce fraud and protect customers. Now let's look at business example, customer classification. Businesses often need to classify customers into groups. A company may classify customers as high value or low value. It may classify customers as likely to churn or likely to stay. Features may include purchase frequency, spend, complaints, usage, and tenure. SVM can learn separation boundaries between customer groups. This helps sales, marketing, and support teams prioritize action. Classification becomes more useful when it leads to business decisions. Now let's look at business example, risk prediction. SVM can support risk classification in finance and insurance. A loan application may be classified as low, medium, or high risk. An insurance claim may be classified as normal or suspicious. Features may include income, credit history, claim pattern, and transaction history. SVM helps separate risk categories based on past data. Risk teams can then review cases more efficiently. Human review remains important for high-impact decisions. Now let's look at business example, email and text filtering. SVM is often used for text classification. Emails can be classified as spam or not spam. Customer messages can be classified by topic or urgency. Support tickets can be routed to the right team. Text is first converted into numerical features. SVM then learns a boundary between document classes. This helps automate sorting and filtering. Now let's look at business example, healthcare and quality inspection. In healthcare, SVM can help classify cases for review. Medical data may be classified as normal or abnormal. In manufacturing, product images can be classified as good or defective. Sensor data can help detect quality issues. SVM can support early detection and faster triage. But it should support experts, not replace them. Human judgment is essential in high-risk areas. Now let's look at when should you use SVM? SVM is useful when the problem is a classification task. It works well with clear class boundaries. It can perform well with smaller or medium-sized datasets. It is helpful when there are many features. It is often useful for text classification and structured classification problems. But it may be slower on very large datasets. It also needs careful feature scaling and parameter tuning. Now let's look at common beginner mistakes. One mistake is using SVM without scaling features. SVM is sensitive to feature scales. Another mistake is choosing a kernel without understanding the data. Beginners may also ignore margin and support vectors. Some only focus on accuracy and ignore precision, recall, and false positives. Another mistake is using SVM blindly on huge datasets. Always test and compare with other models. Now let's look at SVM compared with other models. SVM is not the only classification model. Logistic regression is simpler and easier to explain. Decision trees are more visual and easier to interpret. Random forests and gradient boosting often work well on business tabular data. SVM can be powerful when boundaries and margins matter. The best model depends on data, goal, size, and interpretability needs. Good machine learning is about choosing the right tool. Now let's look at final content recap. SVM means support vector machine. It is a supervised machine learning algorithm used for classification. It finds the best separating boundary called a hyperplane. The margin is the safe gap around that boundary. Support vectors are the critical points closest to the boundary. Kernels help SVM handle nonlinear classification. Business examples include fraud detection, customer classification, risk prediction, email filtering, healthcare, and quality inspection. To wrap up, here is the key takeaway. You now have a structured overview of SVM in machine learning explained classification with business examples. Review the core ideas, connect them to examples, and revisit concepts like SVM separates data into classes, what you will learn, what a support vector machine. When practicing. Subscribe to Easy Machine Learning Guide if you want to learn AI through simple explanations and real industry examples.